So far this semester, we have predicted the products of 3 types of reactions. Chat with your partner, decide what are those 3 types of reactions for which we are able to predict the product so far. What's one of them? Synthesis. Okay, and if we have synthesis, for example, we might have Cl2 plus Al. I have an element and an element. What do we get as the product? We get a compound. And I'm going to give you some choices for the formula of this compound. Cl2Al, ClAl, let's see, we have AlCl, A, B, C, D, and then we have AlCl2, and then option E is other. So please discuss with your partner and decide which one of those choices you want. You don't need to write down all the choices. You can just look at them. Well, there's option E.
I don't like option E. I don't. Usually when they give you option E on the test, they say, okay, now write the option. You got option, so good point. Anyway, it's going to be added to.
Okay, what option do you guys like?
How do you say E?
This is option E if you like E. This is D if you like D. This is C. This is B. And this is A. Okay, I got a bunch of E's. Yes, the answer is E because what is the charge of aluminum when it's in a compound? 3+, and chloride is -1, so we need to have 3 chlorides, so it's going to be AlCl3. And we have an even, and we have an odd number of chlorides. And when we have an even and an odd, what should we be using? The LCM. Okay, so we're going to put a 2 here. That gives us 6 chlorides. We're going to put a 3 here. That gives us 6 chlorine. And that means we have 2 aluminum, so we need to put 2 aluminum there. That is synthesis. You will eventually need to be able to pick the reactants of synthesis out of a random list of reactions and say, this is synthesis, and then predict the products. Okay? Type 2, decomposition. So what you're looking for, by the way, when you have synthesis, is you are looking for an element and an element. That's how you'll know you have synthesis. You've got one element, you've got a second element. Decomposition. NH3. What do we have here? That is a compound. So if you have just a single compound, you know that you are dealing with decomposition. And what do we do with decomposition? We just take the elements and we separate them. So you write them separately, then you have to check, are any of them diatomic? Yes, N is diatomic, H is diatomic, and oh my gosh, look what we have again. We have an odd and an even. So we're going to use the LCM. So we want to get 6 hydrogen here. So that's a 3, gives us 6. And on the other side, a 2 gives us 6. And oh, we already have 2 N's, so we're good to go on the N's. So if you see a single compound, you know you have decomposition. If you see 2 elements, you know you have synthesis. What is the third type of reaction that we have predicted products for? Single replacement. And how you're going to know that you have single replacement is that you are going to have a compound plus an element, or an element plus a compound. Doesn't matter. The order of your reactants doesn't matter. The order of your products doesn't matter. Do you know what I mean? You can write your element first, you can write your compound second. You can write your compound first, you can write your element second. It does not matter. Okay? And we have 2 types of this. We have type A, which is single replacement metal. So for example, if we had CuCl2 plus Al. You always need to look at the element right? And which one is this? This is a metal. So it will kick out the other metal. So the metal has to kick out the metal. So if Al kicks out Cu, who's now together? AlCl. Okay, so we got Al and Cl together. And who is left by itself? Who got kicked out? Copper got kicked out. Now, if you look at this, you might say to yourself, have I written my element correctly? Is it diatomic? No, it's not one of Brinkelhoff. Have I written my compound correctly? No, because when you write a compound, you have to look at the charges. You need to make sure the charges balance. So you can't have AlCl, you need to have Al, which is 3 plus, and you would have Cl3 because Cl is -1, and you need to have 3 of them. So it needs to be AlCl3. And at that point, then you can balance it by saying, I have a odd and an even, so I'm going to put a 2 here and a 3 here, and that gives me 3 copper, and that gives me 2 aluminum. Okay? We also have single replacement non-metal. So let's have F2 plus K3P. Ooh, that's fun. You look at your element, and the element is a non-metal. Therefore, who does it need to kick out? It needs to kick out phosphorus because phosphorus is the non-metal. So when it kicks it out, that means that F and K are going together. First of all, I would like you to decide, is the correct order going to be F, K, or is it going to be K, F? It's going to be KF because the metal always comes first. Then you have to decide, do we need any subscripts in this formula? Well, K is positive, F is negative, so no, we don't. That's perfect just the way it is. And then finally, who gets kicked out? P. So P is going to be on its own. And P is one of the special ones. What is P? P is P. It's P4. Sulfur is S8. P is P4. So we have P4. Oh, this is going to be complicated. All right. So let's put a 2 here to balance our fluorine. Except for that, then that gives us 2 potassium and 3 potassium. So I'm actually going to make that 6. So I'm going to put 2 here. Actually, I figure I should do the phosphorus first. Let's do phosphorus. I'm doing phosphorus first because it's got a big number. So let's put a 4 here. That gives us 4 phosphorus, 4 phosphorus. That gives us 12 Ks, so we'll put a 12 here. And that gives us 12 fluorine, so we'll put a 6 here. That's better. So those are the 3 types we have learned so far. Today, we're going to practice a little bit more with the single replacement because not only did we learn single replacement, but we also learned about the activity series, which, if we're on page 61,
the one that we did, right?
yes. The what? Yes, you get the table of activities on the test. Yes, yes. Okay, you do not need to memorize it. Okay. Okay. Shh. Do you remember who can replace who? If you got something lower down, can it replace something higher up? No. If you got something higher up, can it replace something lower down? Yes. Okay. So right now, what we're going to be doing is we are going to be going to page 65. And in these ones, you need to decide, is iron more active than lead? Is iron, which is here, more active than lead? Is iron more active than lead? Yes, because it's higher up. So the iron is higher, the PB is lower. So can iron kick out lead? Yes. can, so this one you would have to actually predict the product. So go ahead and you can do that. But we're just going to take a look at number 24. Number 24, can copper kick out aluminum? So here is aluminum. And here is copper. Can copper kick out aluminum? No, because it's too low. When it is too low, what do you write? NR. What does NR stand for? No reaction. And you don't have to do anything else with it. Okay? So, for 23, yes, reaction. So you will go ahead and write the products. For 24, you just write no reaction and you don't have to do anything else. Yes? Shh, I cannot hear him. Yes. Oh, you good? Okay. So what I'm going to do is I'm going to have you do numbers 23 through 29. All right. And then you are going to do, that's up here, 23 through 29. You're going to do number 33 through 39. Okay, 33 through 39. So that's pages 65 and 66. You can go further if you want to. Page 69, we're going to learn about later, so don't worry about it just yet. When you have finished these questions, you can ask me to see your mole test. Okay? When you have finished those questions, you can ask me to see your mole test. Okay, page 67. And after today, I'm going to actually have a chart of this printed out for you with the activity series on the back so that you can have them and refer to them like at any time, okay? So what we have here is we have a table telling us about the solubility of certain compounds. And what is solubility? Anyone know? Solubility is the ability to dissolve. Okay, so we got that ility. Solubility is the ability to dissolve. And we are talking here about compounds in water, so our solvent is going to be water. And we are talking about common ionic compounds for the most part. Okay, almost all ionic. And what you'll notice in this chart is that we have negative ions. These are our anions, are given on the left. The positive ions are given on the right. And then we finally have the solubility. So what this is saying is that in our first row here, if our positive ion is any of the alkali ions, so that means like if I had a compound that had Li3PO4, okay? So if I put lithium with phosphate, if I put lithium with oxide, if I put lithium with, I don't know, SO4, all of those are going to be soluble. Now, what does it mean to be soluble? Soluble means it will dissolve. And that means that if we are dealing with a reaction that is taking place in water, which all of our double replacements will be taking place in water, that means that these salts will all be what state? If they are dissolved in water, they are aqueous. Okay, so if you have lithium with anything, it's going to be aqueous. If you have sodium with any other ion, it's going to be aqueous. If you have potassium with any ion, it will be aqueous. So if you see any of the alkali metals, you know that that compound will be aqueous. We're going to put a bracket around the hydrogen ion because I really only want to be dealing with the ionic compounds at this point, and the hydrogen ion gives us acids, and that's going to be a little bit more complex, okay? So we're just going to leave that for now. Ammonium, just like the alkali ions, when we put it with everything, all other anions, all anions, it is going to be soluble. So it doesn't matter what you put it with. If you have NH4, pick an anion, any anion, what would you like? Ammonium carbonate? It will be aqueous because all of them are soluble. And remember, soluble means it will dissolve, which means it is aqueous. Okay. Acetate and nitrate. So now we've been looking at positive ions so far. Now we are looking at negative ions. So we have both acetate and nitrate, and they are soluble with any ion you want to pick. Somebody pick a metal for me, please. Copper. So if we have copper and we have nitrate, it will be what state? Because all of them are soluble, it will be aqueous. Okay? Now we get into the more interesting ones. So if I have chloride, or if I have bromide, or if I have iodide, and I put it together with silver or lead or copper plus or mercury 1 or mercury 2, it is going to be low solubility. And low solubility means it does not dissolve. Okay, so it does not dissolve in water. So if it does not dissolve in water, what state will it be? Solid. So if we were to pick one of those anions, okay, so if we were to pick, say, iodide, okay, and we put it together with lead 2, if we had PbI2, that would be a solid because the lead with the iodide is low solubility. But let's pick some other metal. Ooh, let's do gold. Gold sounds fancy, right? Let's do gold with bromide. So Au Br3. Here's bromide, and gold is not in this list. And if it's not in that list, it falls into the category all others. So if you see all others, that just means it's not in the list. Okay? So gold bromide would be soluble, which means that it would be aqueous. Okay? We'll take a look at one more, because this one kind of confuses people some of the time. Thank you so much.
Thank you.
Let's take a look at this one here. So we have sulfide is soluble with hydrogen and ammonium and all the alkali ions, but you should know that already because hydrogen is soluble with everything. The alkali ions are soluble with everything. And ammonium is soluble with everything. Yes? So it should not be surprising that sulfide is soluble with all these things, because all these things are soluble with everything. The only new ones here are beryllium, magnesium, calcium, strontium, barium. Okay? So if I gave you barium sulfide, is barium sulfide aqueous or solid? If it's soluble, it's aqueous. If it's low solubility, it is a solid. So we look at sulfide and we look for barium. There's barium right there. That is soluble, so it would be aqueous. What if I had zinc? Zinc sulfide. Zinc sulfide would be solid because zinc is not up here, so zinc falls into the all others category, so it would be, zinc sulfide would be a solid. Okay, you get the general idea? All right. So if you have a compound which is soluble, this just says what we already talked about. Soluble means it will dissolve and it will be aqueous. Low solubility will not dissolve, it's going to be a solid. So please tell me the state of barium sulfate. And you're going to start by looking up the anion. So you're going to start by looking up sulfate. Okay, there's sulfate. And then you're going to say, what does sulfate do when it is with barium? Well, when sulfate is with barium, it is low solubility, and that means we're going to have BaSO4, and it's going to be a solid. Okay. Aluminum hydroxide. Let's look up our anion. Usually we look up the anion first. So number one, look up the anion. The anion here is hydroxide. Here's hydroxide. And we don't see aluminum. There's no aluminum anywhere. Where is aluminum? If it's not here, it must fall into the all others category. And if it falls in the all others category, that means it is low solubility. So AlOH3 is going to be a solid. Okay. Now, this last one is tricky. Okay. Imagine you're speeding down the highway, like, I don't know, at like 150 kilometers an hour. That's bad, right? Who should you be on the lookout for? The police. And we sometimes call police the coppers. Yeah? So you need to look out for the coppers. Why are we looking out for the coppers? Because copper just doesn't have one charge. It has two different charges. It's got multiple different charges. We have copper 2+, and we have copper 1+. And if I give you a compound that involves copper, you have to decide, is this copper 2+ or is it copper 1+? Well, we got copper here, we've got chloride and chloride. Each chloride is -1, and that means that copper is 2+. So this is Cu 2+. So when we say copper chloride, we look up our anion, the chloride, and then we're like, oh, look, here's a Cu. Except that this Cu is just Cu+. It's not Cu 2+. Where would we find Cu 2+? Up in the all others. Cu2 plus is up here. So watch out for the coppers. Okay. And that means that if Cu2 plus is up here, it is soluble. So CuCl2 is going to be aqueous. Okay. So in addition to minimum finishing these, if you can, go further, finish up those pages, finish up 65 and 66. In addition to that, you are also going to go through page 69, and you're going to decide if I have Ag and Cl together, is that going to be solid or aqueous? And because we've got a few minutes here, I'm going to try and run off that sheet for you so you don't have to flip back and forth. Yes? You're good? Okay, I can do that.
Is that yours?
Oh. I didn't say that wasn't Cu2 plus. I said that this one, this copper here is not Cu2 plus. That copper there is Cu. So we need to look up Cu2 plus, so it would be in the all others category. Good question.
Okay. Senior to is not. Senior